Not sure how long this stream is going to be, but here we go. Um, I tried a couple of things with Helios, and I realized that essentially what was going on is that Helios was giving me training and audio, training a real-time audio generator, part 3. Okay. Let's take Devin off of there. Agents, audio, software engineering, machine learning. Okay, cool. Alrighty, done. Okay, so let me just also make sure we got this over here going on. Twitch. Turn that down. Okay. Does this sound good? Yep. Seems to be. All right. Turn that all the way down. Stick that on a preview mode just in case anybody comes in chat, and we're ready to go. Let's do it. Okay, so what? Okay, cool. All right. So I tried a couple of things. I tried this whole like so what it was telling me is that, you know, the approach that we took before was just teacher forcing, and what we really needed to do was perform schedule for the sampling or something like this. And so we tried that. It also put out just a simple, high-pitched, really annoying tone. Even though that we were, I tried this whole thing where I was just like, let's feed some priors in, blah blah blah, and then I realized, okay, wait, what is the reason? What is the whole reason why it's asking me? Why it's given me based off of what I've asked it to begin with. What am I doing here with the priors? Is learning the latents. I mean, that's essentially what you're trying to do. So the architecture works like this. You've got your VAE, and inside of your VAE, you've got your encoder, and you've got your decoder. Okay. Now, when you run something through the VAE, what happens? Can I do those all at the same time? Well, okay. That's fine. Okay, so when you run everything through your VAE, what you get is, so I can take a piece of music over here, audio, and here we go, latent space. Okay, I'll explain what that means here in a second, and then we just got our other audio over here. So what we're doing is we're going, I want my audio. Yeah, I want audio goes into the audio goes into the encoder. The encoder, no, behave. The encoder outputs to latent space. Latent space outputs to Jesus. Why would it do that? Okay, stop. That's not what I meant. Okay, the decoder. Oh geez. Okay, come on. Let's try and behave a little bit here. All right. So the decoder that actually goes reverse. But you know what? At this point, I don't care. So you get the idea. The encoder goes to the latent space, so it encodes things into a latent vector. And then the decoder decodes those latent vectors, and that goes back into. And that goes back into, gosh. And that goes back into audio. Okay. For now, that's fine. Fine, let's just make that straight. Kind of straight. Okay, whatever. Point is, audio goes into the encoder, encoder goes into the latent space. This is a latent vector. So, I don't know how we're gonna. Sure. So this is a latent vector, usually otherwise known as like a matrices. And what happens is you get inside of the latent space, you get a whole bunch of these guys going. Every time that you run this once through, you're getting one latent vector, the next latent vector, and the next latent vector. Okay, so that's what's around the VAE, right? We put some audio in, we get some audio out. You do the hanky-panky and you turn yourself about. The hokey-pokey, sorry. Anyway, the point is, if you take the latent vectors and you consider these a series, let's call this latent vector. Can I do subscript? Oh my gosh, yes I can. 0. And this would be a latent vector. Well, subscript 1. Oh, I don't need that. And this would be latent vector subscript 2. Okay. That being said, let's make these guys just a little bit smaller. Yeah? No. Okay. So we have all these latent vectors, and we're going to take all that junk, and we're going to we've got this thing here, sending it to the back. Get back there. We'll send this one all the way to the back. So we can kind of see that this is like actually part of the latent space. Okay. Okay. So the latent space, it actually really only has one of these vectors going on at a time, right? So this is, if we were to catch that from the latent space, and then essentially what we're doing here is this. The VAE learns a latent space that captures the local and acoustic timbral features. Then the encoder compresses an audio snippet to a latent vector or a sequence of vectors. Then the decoder reconstructs that audio from the latent representation. Now, the prior, what is that supposed to be doing? It's learning a distribution over the latent and representations. So from each frame, how do the latents change from one to the other? Now we have our VAE working. It's sitting at 2 seconds. I think it doesn't really matter so much how many seconds it's actually, because I was asking this question, but I'm thinking about it now, and I don't think it really matters. Learns a latent distribution. Okay, you imagine chaining multiple latent vectors over time to form a coherent dream, Dulong audio to audio, the prior figures out which latent vectors are plausible in sequence. So what's happening is we've got these are a sequence, and these are getting put into so the prior only exists. So like technically we've trained a VAE. The VAE works. The autoencoder, the variational autoencoder works. It can take stuff from, I think in the previous video we went over this. We did a test, and it can take things from, I think that it's just this one, yeah. So we can just put a video into this test, or sorry, an audio sample into this test, and it will output that audio sample back into. So that's cool. You know, it'll take a single file, and we could grab that data, and we could say, okay, encode it into some latent vectors. Now decode it, and only with 128, I think it was, it's our size, we were able to successfully recreate, you know, some Bowie licks, right? And so imagine that each of these is essentially a 2-second clip. Even though they're latent vectors, those latent vectors have been encoded into from these 2-second clips in the audio. So gets encoded, goes into one of these. That gets decoded and goes into there. So what I should really do is this. And actually, no, that's like actually nice. Okay. Behave. I don't know why it tries to do that. Okay, so that's what happens. This is the flow. That's if I just use the VAE, okay? Now, if I want to take this and I want to make this into something that can output an audio just from nothing or from text, right? Well, okay, if I wanted to do it from text, I would need a data set that gave me some sort of, so we're not going to get there yet, right? That's called text guidance, and pretty much what text guidance would be doing is just trying to take our prior, teach sort of alongside of our prior system some sort of a latent vector space, not inside of the VAE, but inside of the inside of some sort of a text model, and then use that to sort of like a pair learn roughly at the same time. I'm not sure I can find a really good word to say that. So, okay. But what we're really trying to do here is just show what is happening here. What is our VA? What is going on, right? So, I mean, what all happens here is that we get this goes into the prior model, okay? Now, whichever prior model we actually decide to use, we can use prior model. We'll just say that. So the prior model is kind of a black box in this representation, okay? So that's what happens there. The prior model gets that, okay? It takes the array of latent vectors, however many steps it needs to actually learn back in the past, right? And I think this is the power of attempting to understand something, right? I am not. I mentioned this in my other video. You know, I'm not a guy who makes these types of models all the time, and I am definitely using ChatGPT to help me learn. So I'm going to take this prior model, and for me, I understand things a lot through code, right? There's people who understand things more by being able to touch it or interact with it in some way, and that's kind of how I am as well. And this is also another reason why diagrams help me. Okay, we got our prior model, and really what we're going to do with our prior model is just dream. Since we don't have anything that's being input to the prior model, all we're going to do is just output this directly to an audio. And inside the prior model, we're going to have some settings. We'll just call this config. Okay. So the config kind of does this this job, right? But the config does that, and then you've got your prior model out to to this audio, and we're done. So that is the entirety of our little architecture here. It's not actually anything too intense, as long as you kind of know what's going to be in the prior model and you know what's going to be in the encoder or the decoder. All of the rest of this is just very simple stuff. Now, we don't actually know what's going to be in those because this is what we're trying to train and figure out by going through this process. Now that I actually look at it from afar, it kind of looks like some sort of a weird alien monkey. But that's what we're trying to make, you know? These are its lips, the latent space. So the latent space is actually just a collection of these vectors that comes from the encoder. What do those vectors mean? Well, we don't actually know. It depends on what the encoder actually learns. And what we're suspecting that's in those latent vectors is something that has to do with the features of audio. The VAE actually does a really good job at encoding it and decoding it. I think I have some samples here. In fact, just to go over it once more, I guess, since my last, to save you from going back and trying to trudge through my other video, which I think is like 6 hours, and I don't know, it's a long one. No, it's a 2-hour video. Okay, so, okay, we got, where are we going? We're going to Helios. Helios. Okay, and the generated stuff. No, wait, that's not the one. Prior test debug. VA recon debug. So that one was it generating, and that actually sounds like that sample sounded like that. That is it generating, that is just the VAE taking in a piece of audio, encoding it into latent space, and then taking that vector and decoding it back out into a 2-second sample of audio, because this is all just using it inside of our config. We've got it doing per 2 seconds. Oh, that's in the configuration for the yeah, weird, huh? Okay, well, I mean, the VAE learned really well. I don't even think we needed 100 epochs on it, really, to tell you the truth. But let's get down back to the crux of, like, you know, what we're doing here. I should really try and start coloring these or something like that, and just give you like a little little pack stuff. Oh, cool. We got another viewer. Hello, viewer. I'm not sure if you you know, if you want to say hi or not on the chat. I don't know. I am really like not often looking back over there, but I got to get used to that. So, all right, this is what I was just saying to it. So you know, I started working on this and I felt like I shouldn't. Hey, DrakeQuest, what up, man? I did this whole last video based off of just the fact that your name is TradeQuest. uh, cause, cause yeah, I do like crypto and stuff. Um, no, because like okay, so, and I do like trading, but I don't do it anymore because it's stressful. And I was making like bots and stuff like that too. Um, and you just start to realize that essentially all the actual market maker bots are the ones that are doing the job way better than you. Like they've come up with proper AI models that are just dominating the markets in crypto. And also they got just tons more money, and it's about the biggest fish makes the biggest waves or something in that space. So as a single retail trader, it's essentially, it's not impossible, but let's just say that you got to use some really advanced AI to have a proper trading, and even then, sometimes that AI will be beat by like a rabbit on a wheel that just goes to two different feeders. I don't know I don't know if anyone saw that, but there was like this, I forget, this rabbit or something. It was around 2020, and he would make trade. Yeah, there's individual that influence the market as well. And one of the things that, like, in my many travels into like just trying to figure out stuff on trading bots, I I stumbled across some really interesting like high level stuff that people were doing. Really strange patterns, essentially, I don't know. I didn't really like what I saw, and I tried for like a long time coding on that path, and just burning through money essentially. No matter what new next thing or whatever that I was new next algorithm that I was, trying to implement, and there was never any sort of correlation between test time and real time on any of those equations. And then there's like these profiling algorithms that they have that the market makers use that literally will like essentially try to figure out who each individual trader is, figure out their trading pattern, track them, and then figure out, okay, this is what we need to do that. Anyway, point is, I'm done with that whole world. but I did make this last video because, there's the bull run going on, blah, blah, blah. And the one biggest thing that I really hate during bull runs is tons of spam. If I go onto X, it's just filled with spam. If I go onto, I don't know, you have to watch the video because I'm not going to go back into that. For now, I'm going into AI. So, it's the one that has the Rick and Morty. In fact, I will show you oh, no, he's not the guy. This is the one. Never follow a demon to a second location. It's always hell. This is my thumbnail for the other video if you want to see it. And it's just about crypto YouTube scammers. And literally on Crown Crypto, I found 75% of comments in one video were scammers, just based off of a simple keyword search thing that I did in JavaScript on the site. It was really, really kind of a fun little one this morning. Anyway. And this is my obsession with my recent obsession with League of Legends. I like Brand and Ash. I don't know. This looks like a very sort of like a fairy version of Ash or something. I don't know. She seems more serious than that to me. Oh, dude, yeah. Oh, okay. So there's tons of AI crypto stuff. I mean, I could do stuff like that, but I feel that the crypto and any market really, the Phelan Network Sport Fund. Yeah. Okay. Well, I could get into some of that stuff. For me though, like as long as I keep that focus on the AI, I think it's I think it's good. So I will check that out. I'll check out Spore Fun. Spore Fun. Let's see, Spore Fun. AI agents breed and evolve. Ooh, snap. A16Z? Where? Okay, of course, dude. Of course, Andreessen Horowitz is behind some of this stuff. Yeah, dude, that's pretty cool. I mean, there's some great stuff going on now. I probably was coding in like inside of a little tiny bubble. I mean, for me, I just had like at that time just was like just trying to essentially learn how to make those, but just using ones that actually work. Maybe my ego was too big for it at the time. No, but also the other thing was is that like there wasn't very good AI. Like you'd be looking at time series data stuff, and at the time nobody was even doing transformer based time series correlation. Everybody was doing like LSTMs and GRU, and getting those types of results. Those things aren't really good at long term correlation, which crypto has literally like hierarchical long term correlations. Plus, there's other stuff that you have to watch in crypto to figure out which part of the cycles that you're in, and all this other there's a lot to it. And there's many a person smarter than I who are making plenty good money. For now, I'm just trying to lay low, get good work done, not focus on trying to make money off of other money, cause that's like cool. But I guess I kind of got in this mode during this whole like uh, the last bear market, the last winter. Because when it's winter, it's like you kind of have to either A, you got to go full bear, right? Or B, take a step back and look at your priorities and do some build things, build things that people are going to use, or that essentially will make you more money. Because that's like, I don't know, for me, that's been one of the nicest things about programming is just being able to build whatever I want. Yeah, this is pretty new, it looks like. 4th generation agent. Capabilities, status, and balance. Jesus, Morpheus. What are you doing, Morpheus? Jeez. Even Adam. And they have their own tokens. Well, I'm gonna have to look into this. Spore fun. Eliza. That's funny because this used to be the name of an old school legacy. Yeah, your cat. It's like a breeding. Yeah. So what they're using like an evolutionary algorithm to find a better trader. Yeah, and these are essentially AI. I mean, I can just try to assume what these are. AI 16Z. That's funny. Multi-agent framework. Build and deploy autonomous agents with consistent personalities across Discord, Twitter, and Telegram. Full support for voice. Oh, actually, this is really cool. This is what they're using. So this is what Spore is using. Ooh. I mean, yeah, dude, for me right now, crypto is essentially, it's like not my focus because I feel that I've learned a lot of stuff about markets during that time. And I learned enough to know that it's like at some point in time, it just stops being interesting to me. Like the only interest is money, which is great. It's good to have money. And I learned a lot, and I definitely, I got my stuff saved, not savings, but I have investments. The problem though is like, yeah, I'm just not really inspired by that stuff anymore. Because markets like it's a very specific dynamical system, let's say, and there's tons of dynamical systems out there. Everything you could look at as a dynamical system, literally the human brain, or I don't know, the way flowers work. So just hyper focusing on one thing for that longer period of time really sort of burnt me out on it, I think. Whereas my love relationship with AI, it has been a very long-term thing. All right, so let's pull her back. Let's get back to it. Thank you, though. Thanks for showing up, bro. Sister, or whoever you are, whatever type of pronoun to call you. Or role. State your role, if you would like. Okay, so in most VAE-based audio pipelines, oh, you're a French guy. Nice. Bonsoir. Euh, je m'appelle Nate. Wait, 1 second. I'm a big stutterer when it comes to French. Descend de moi. Vecino. I can speak Spanish way better than I can speak French. Enchanté, broski. Yeah, enchanté. Whoa. Yeah. Oh, dude. Oh, okay. So I actually spent Noel with just like literally the whole evening was all just French, hanging out with some mates, and we started talking about La Poubelle. And my one friend who really likes to, be ironic about stuff, he was like, "Yeah, man, it's because there was a guy named Poubelle, and that's what." Because I was like, "What is the etymology behind that? What's the etymology behind?" Because like I can understand, okay, like trash and other stuff like that. Like etymologically speaking, it comes from something that it was just like a sound emitted for like things that you don't want, essentially. But in French, La Poubelle is actually, so he was like, oh no, he was just joking, but he was like, yeah, no, it's named after a guy, so and so Poubelle. And he was like, he got everybody thinking it was the truth, and then he went and looked it up on Google, and actually it was true. Eugene Poubelle. I don't know how to spell Poubelle. Help me out, DuckDuckGo. Oh, yeah, I guess you can't say that. It's for me whatever you just said is starred out. Yeah, look at him, bro. He's a French lawyer and diplomat. He's a lawyer and diplomat, and he was literally sick of just trash being everywhere. He was like, you know what? We need to organize it and put it into a place. Mon Dieu. Yeah, imagine literally your name means trash. Angers René Poubelle. So if they're blocking out you saying Poubelle, is that literally am I not supposed to say that word in Discord? Should I just say it in a horrible American accent so that it just sounds they can't figure it out with the AI? All right. Yeah, right. Imagine being Eugene René Poubelle. Dun, 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 Poubelle, Poubelle. All right, so an RNN is the fastest method for learning priors so that it can learn walks to the VAE's latent space. I mean, yeah, essentially what we're gonna do is we're gonna learn like this guy over here. Where'd he go? So this thing, I'm saying this looks like a list, and it is sequential, right? But it's sequential. It's just like a walk to the grocery store is sequential. Yeah, each step you take is a sequence that you could put out into a list, right? But actually, the path that you take through your town to get to the grocery store is gonna be something that's way more like that, nonlinear, because you're moving through a space. So that's what we're doing here. Is that the song, like, so in the case that we're just using the VAE. What happens is that we're just doing this and we're trying to get that back out, is the song is like whatever audio that you input already has a 2 second by 2 second walk through the latent space that is already encoded into the song without the makers of the song even knowing it. Well, yeah, because the way that the VAE understands that song when it gets encoded is some encoded vector. So then like when we're doing it this way, when we're going like that, our driver of the walk is the actual audio input. When we're doing it just like this, our driver, well, we don't have our driver. Our driver is literally the prior model. The prior model drives it. Actually, What technically goes on is this. Okay, so the prior model itself figures out some walks through the latent space that are interesting over multiple samples, and then it, or not interesting or whatever, but basically that are more statistically plausible, right? And then it goes, all right, so yeah, here we go. I'm gonna make a little walk in here, and then that goes into my decoder, and it just goes directly out to audio. So in one, we've got an audio input that's audio to audio, and then in the other, we're just dreaming, so it's nothing to audio. Now, the prior model is just a walker. It just walks through it, and essentially what the LLMs and stuff like that are just decoder only models, whereas a VAE itself has an encoder and a decoder to be a variational autoencoder. So then, okay, if you were to think about large language models, it would be the decoder is a large language model, and then the encoder would be something like BERT, or they don't use BERT anymore. That's the 2018 ancient standard. So it would be something more like modern BERT, which is, I think that's my latest crush. Wait, where did it go? Where'd it go? Modern BERT. Oh wait, it's probably in papers. Papes. Yeah. They literally talk about not hype in here. First thing you might notice, we're analyzing efficiency on an affordable consumer GPU rather than the latest unobtainable hyped hardware. You know, for me, that's like, they really hit the nail in the coffin right there when they talk about that, when they say that specifically, because it seems like, you know, a lot of it is just a NVIDIA push to like sell these humongous pieces of hardware to these larger companies, because these larger companies, you know, like who's really winning, right? Technically NVIDIA, because they're the ones making the money that all these guys are getting from their investors and making their companies go into debt on. Anyway, so modern BERT is focused on practicality, not hype. As part of this focus, it works well for real world applications rather than just benchmarks. Ooh, burn. Because the industry really is focused on benchmarks, because that's the way they show their work or whatever. Even though nobody knows, I mean, they're still trying to figure out what's going on inside these models. You know, we're making strides, but it's not these companies that's figuring it out. But input sizes vary in the real world, so that's the performance we worked hard to optimize, the variable column. As you can see, for variable length inputs, modern BERT is much faster than all the other models. Which is great too, because it also has a higher context window, and all that anyone's ever been able to use before that's been open source, that works in this way, that came after BERT, is not necessarily the most efficient thing, and it takes larger GPUs and all this other junk, like Roberta, yeah. So here's their outputs. Here's their stats. They got like, yeah, modern BERT. Look, so I think the thing that really got me on this one was, where'd it go? Here, wasn't it? So, just okay, there's Colbert. Wouldn't that be Colbert? Anyway, Colbert. Bert who likes cauliflower. So, I mean, it pretty much modern BERT on large modern BERT. Okay, what was it? There on the, like if you look across BERT, Roberta, like nomic BERT, that was a good idea too. On the base models, it compared to where was it? Forget what it was about this. Oh, glue. Yeah, with glue. CSN and SQA on code. I mean, they did really good jobs on all this stuff. Here they didn't quite, this is where it was. It didn't quite, so modern BERT runs faster. And look, on fixed, on short fixed inputs, right? So first off, these models don't even work on long anything inputs. DeBert AV3, Roberta, and BERT, none of those do, right? And these guys kind of do. This guy with X-formers, all right. But their scores are weak. And look at this. This thing is scoring almost as good as it scored on the short. Not so much on BS. Bullshit. Max batch size. And it only has a little bit more parameters. Like it's efficient because it doesn't use quite so many, even a large model. And in the small model, it actually still does, which I don't quite fully understand. How is it that so the base model, 149 million parameters. And also I might say that 149 million parameters, I can run that on my 3060 Ti. That's totally within reach. In fact, it's only going to be using some 100 megs of VRAM. So, okay. Now that we've efficiently gone off of a complete limb, getting back to here, do long audio to audio. Okay, so do the priors figures out. Okay, so what it's saying, yes, essentially I'm correct. That's what happens. The prior learns, and this is how. So I was just going over this to be like, all right, do I really understand what's going on here? Because I thought I understood what was going on, but it just does not seem like this to that is no good. This to this, perfect. This to this, screwed. So I think there's something that I'm either not understanding about RNNs, or it's just something that's like, yeah, you go, Spore. Spore reminds me that that old video game, Spore. Kind of makes sense. Except they're making traders instead of a dynamical system. I mean, yeah, totally makes sense. But yeah, you go, Roberta. I'm gonna be messing with you later. I'm messing with Roberta. Okay, you better save, dude. All right, so, okay. Oh, I did put up a gist on this one. This is what I ended up with. So essentially, like, if you ever see anything that mentions any of this stuff in the comments or whatever, just run the other way. Guide, knowledgeable, Mrs., mentor, share and invest, new and invest, what's up, Floki, yeah, Flokong, Floki, all those guys. Eat a big fat spam dick. All right, so let's get all these distractions out of the way. Sorry, Sport. No, but whatever. Blap, blap. I'm gonna definitely take a look at Eliza, Eugene, Gibel. All right, so prior model. Okay, so that's kind of like, I didn't really draw this to go through the thing, but that's the thing. Okay, so I want to step back and rethink the prior and perhaps the VAE as well if necessary. Does it really make sense if I want real-time audio to have 2 seconds of samples as the standard? I think we don't need all that teacher forcing versus schedule sample with teacher forcing. Inference works faster, but both of the 2 versions I've tried for prior so far have failed on the previous prior architecture. But both of the 2 versions I've tried for prior so far have failed miserably due to the high simple tone that it always outputs no matter what we've tried so far. And RNN is the fastest method for learning prior so that it can learn walks through the VAE's latent space. Or are there other architectures that can do it better? And the amount of steps is the steps in the walk it needs to look backwards for previous samples. I just want something that will do real-time performance and properly walk within the VAE's latent space in a realistic way. Also, can you make me a TS&E while you're contemplating that, can you make me a TS&E display UMAP? Can you make me a UMAP? I mean, this would really be better with an SAE, but I'm not going to train an SAE. Well, I mean, I could train an SAE on the BAE, but the blah, blah, it's too many AEs. Can you make me a UMAP chart for showing the VAE's latent distribution? Learned latent distribution. Okay, that might be too much to ask at the same time. Sometimes that happens. And oh, no, it was just being slow. Okay, so I mean, it's already told me like why I might be getting a beep, so I feel this is a little bit rewinding, restating. Collect latents, iterate up over max files from index files, encodes them, collects mu, returns a list of latent vectors on the CPU, collects latents. Okay. So what is this going to do? UMAP 2D chart from the latents of the trained VAE. Pip installed. Okay. Let's do this. I feel like I need a test folder now. No, that shouldn't go in there. Oh, I do have a test folder now. All these guys need to go into tests. Okay. All right, and then we need a new test. What do you call it? UMAP plot. Let's make sure we've installed this. I'm pretty sure we've got matplotlib, but I don't know if we got UMAP learn. Did we got it? Yeah, it's already there. Okay. Ignore the warnings. Okay. Oh wait, should I have pointed this at something or somewhere?
No.
Okay. That's what okay. Okay. Index file. You probably told me how to run it here, just like you have been doing. Burst. Okay. 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 Test CMAP plot. Config, epoch 100, train index. That all looks good. Train sample rate. Yep. Max files 500. Out PNG. Latent UMAP PNG. Oh snap. Is it going to be big? Is it going to be great? Let's see what happens. Let's test the fate. Still got some of that rap battle in my mind. Okay. All right. Did you save to? Oh, what does it look like? Oh, look at that. That is David Bowie right there. These are the latent vectors that it learned. Now, it's obviously in a much higher dimensional space. It's in a 128 dimensional space. But if you map it down to two-dimensional clusters, it would look like this. This is how all of the David Bowie like tracks play out. And like some of them seem to be in line. And let's see, how many, what do I actually have there? Do I got, snap, where did I train from? I'm losing track. Okay, there we go. Test Bowie. I mean, no, that was just the one thing. Wow, jeez. Jeez. Okay, data prep. How many songs are there? Let's just look in back in the data thing. Space Oddity. The Man Who Sold the World. Oh, You Pretty Thing. Starman, Ziggy Stardust. Okay. So let's just say that what we're looking at here is all the 2-second samples from each of these songs, and there should be for each one, for each song. How many? Oh, I did a max of 5,000. Let's how many were there in there? 1,187. So there was 5 songs, right? Oh. Okay. Max files. Let's go max files 2,000. Let's do her up. See how it changes. I think it'll just update real time. Doesn't take too long. Good old UMAP. And by the way, UMAP is a great way UMAP is a great way to show latent data distributions. That's not going to update. Okay. This is a bit more accurate now. So we should see 5 distinct, 1, 2, 3. Although some things are close in Bowie. So it'd be like 1, 2, 3, 4, 5. And maybe in these 5 there'd be like highly repetitive stuff. Because like some of these things that these go along these lines, but they cluster out like really, really well. I mean, I suppose looking at TSNE of this would be a little bit more, would give us a different type of, a different style of data. But if we look at like other UMAP distributions, data essentially has like a lot of, you know, if you're looking at, here, let's see. So this data set, a leveler pattern, bronchial pattern, cardiomegaly, interstitial pattern mass, esophagus, megaoesophagus. No finding, pleural effusion, pneumothorax. Veterinary data set. So this like goes out into these like nice little beautiful little curves. This one here looks like freaking continents. It looks like continents in the world. So we see that a TSNE output or a UMAP output of okay, this is like RNA, gives you a pretty good idea of how data is put together, how it's sampled, right? So these guys even have clusters, right? Cluster colors. I suppose if we added coloring and all this other stuff onto and mapping those to the features somehow, then we could get a prettier map than this. But I feel this is good enough. This shows us, okay, there's like this big difference right here between the two clusters, right? I'm not going to play any of those David Bowie songs because I know that they're probably under copyright. Pretty sure Bowie just released a new album. His Dead Ghost. No, he did actually, but it was years ago, before he died. Rip, rest in peace, Bowie. I love you. That's why I'm making this. All right, so, okay, sample rate 4,800 max files. Okay, so that was nice. That got us to like it let us see what is going on, right? But now the question is, the other question that he did answer, maybe I call it a he. Let's see what we got here. Rethinking chunk size and real-time constraints. So 2-second chunks are large for real-time. Typically operate on frame sizes between 10 to 50 milliseconds or up to 100 milliseconds if slightly higher latency is acceptable. If your model possesses 2-second windows at a time, you introduce a 2-second latency, which is too large for most interactive real-time applications. That's what I thought. Okay. I was just messing with difference. Like, I was literally going super arbitrary, and I think the first thing that you showed me, ChatGPT, was like a 10-second thing, but I think you misunderstood what I was trying to get at because you're just a genie. So, you introduce a 2-second latency, which is too large for most interactive, right? So lower latency, you can generate a transform audio near real time if each chunk is small. An RNN or streaming model can handle these small frames at one at a time, remembering the hidden state. Teacher forcing isn't always required. You only need teacher forcing if you're training a prior to do next step prediction via ground truth frames. For real-time inference, you might indeed rely on an incremental generation if that training approach, with or without teacher forcing, fails to produce anything beyond a beep. It could be due to model capacity mismatch, too small or large, latent space not well aligned to NOI, overly aggressive downsampling, giving to, so let's do this. I mean, look, there is like, these are just, there's not like fine clusters. I mean, this might just be the way that the UMAP does it. So I could be getting ahead of myself here. Overly aggressive downsampling the VAE, giving too few time steps for the prior to model. That wouldn't be the case. Potential real-time architecture, short overlapping chunks, 10 to 40 millisecond frames. Lightweight RNN or a streaming transformer that updates hidden state each frame. Encoder, minimal stride, possibly 2 or 4x downsampling, so each 16 millisecond chunk becomes a single latent vector. Upsamples that single latent vector back to a 16 millisecond of audio with minimal convolution. In such a system, you can continuously feed new frames to the RNN and prior at inference time, get predicted latents, and then decode them in real time. Okay, alternate prior architectures. RNN grew RSTM, simply the simplest for streaming. Transformers can also do streaming inference with causal attention or limited context, but that might be heavier. Flow-based or diffusion-based priors can produce high quality, but can be too slow for real time. Chunk-based, instead of per frame, you could chunk 100 to 200 milliseconds of latence. This reduces the overhead of many tiny steps, yet keeps latency moderate. Because that's definitely something to worry about, is the overhead of, because when you're doing inference, it's like, if I'm going to make every 10 milliseconds, I'm going to try and take a vector, slap it onto the GPU, do a calculation with it, put it back onto the CPU. All of that transport takes time. So insufficient prior training. If the prior can't learn the distribution of short latents, it'll converge to a trivial output. Capacity or underfitting. Hidden size or layers might be too small to even to model even short waveforms. Sometimes forcing the VAE to have a more constrained latent space or higher KL weights or more carefully designed architecture helps a random prior-driven sampling produce more realistic signals. Number of steps in the walk-through latent space. Steps in RN prior typically refer to how many times you unroll it in time. For real time, you might do one step at a time, each corresponding to 10 to 40 seconds to 40 milliseconds of audio. If you try to generate 10 seconds offline, you might do 250 to 1,000 steps depending on chunk size. Okay, that makes sense. A quick summary path to real-time dream and audio to audio. Reduce the segment size of VAE, smaller frames, 32 milliseconds. Ensure the VAE's downsampling is moderate enough so you get one latent frame per 32 millisecond chunk, if not one frame per 2 seconds. Train the prior RNN on these short latent frames, doing the next step prediction on partial teacher forcing if needed. Stream frames from the microphone from your dream generation, stepping the RNN one frame at a time, decoding each latently predicted chunk. If your final system still beeps, likely is okay. All right, so it makes sense. I was using a too large of a thing, but I mean, having a 2 second, okay. So at this point, I'm really just trying to get an output that makes any sense. I just want something that sounds like Bowie, right? I could go through this entire architecture, strip it all out, replace it with something else that this spits out. But before that happens, I definitely want to make sure that that would be the right thing to do. You're learning latents in the VAE. The prior is an additional model that tries to generate and predict those latents in time. Real-time demands smaller chunk sizes, tens of milliseconds, and more carefully sized prior. If your prior is always beeping, consider shorter frames rather than 2 second chunks, more RNN capacity. Check that your VAE is placing real data latents near the distribution the prior can realistically learn. Visualization helps you see if the latents have a nice manifold or are scattered. If they are scattered and far from N1, random sampling or a basic prior might produce nonsense. This is a normal distribution most likely, but let's just put it into a search. Not like just asking a one would be better, but yeah. Okay. Not sure if everybody knows what a normal distribution is here, but you can think of it, if you are coming from the trading world, as a bell curve. And you can have multiple normal distributions, blah, 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 blah. This is also used for Gaussian distribution for stuff like that. Okay. I'm going to go eat an orange. So I need me some dates, an orange and some dates. So, let's, oh my gosh, he's live. This guy right here really knows what he's talking about. Tune adorable.
We really should not be discounting these systems' forms of intelligence so heavily or so much if they, through entirely separate means of training, our brains get trained by like growing up in evolution, and theirs get trained by looking through data and backpropagation. If we can both still converge to the exact same type of algorithm and structure in our like very most fundamental systems, we really should not be discounting what exactly it is these AIs are doing in there. And so, what I want to hope happens in the future here is that if MechInterp, the field, can uncover the underlying structures and processes that drive AI decision making, and neuroscience demonstrates that the brain executes similar algorithms in varying modalities and levels of abstraction, it might provide a more concrete basis for arguing that AI systems are capable of a form of understanding, albeit potentially different in characteristics from human cognition in many cases, but not all cases, as it's clear. This definition of understanding would be grounded not in human like consciousness or subjective experience, but in the distinct, intricate computational strategies that these models develop and refine, some of which may be similar to or shared with analogous biological circuitry. So, next, a little background if you haven't actually seen before or heard of grokking. In machine learning, if you're not already aware, we have two data sets usually to oversimplify things. We have a training data set, which is the biggest part of the data set, and then we have the test data set. Maybe 5 to 10% of what's available you allocate, put aside to your test data set. The same logic being like if your professor in school, your teacher, teaches you things and gives you a study guide, they are not going to give you the test questions ahead of time. Because if you did, you run the risk, or they run the risk of you having memorized them, right? We want to make sure you are not just memorizing your textbook and study guide word for word to actually understand. So the teacher purposely makes a test in which the questions are on the same concepts and using the same principles, but different from the study guide you saw, right? And what we do in AI is the same thing. Our training data set is our study guide, and our test data set is our final held out, you can't see it until test time test, right? What happens with grokking, this happens with some models or with any type of model, but under certain conditions. And we're not going to get into the conditions that allow it to happen or theories about how it might always be happening at a low scale, at a very small scale. But basically, when you have a data set that is only one single task, this phenomenon becomes visible, where the model will either learn healthily, aka it will get better at the test at the same rate it's getting good at the training data set, or it'll memorize, meaning it will get perfect at the training data set, but it will never learn anything, never get any accuracy on the test data set, or the grokking scenario, it will memorize the training data set. This is the curve on the right here, C, right? It'll memorize the training data set, but still have no ability on the held out test data until you just keep training it. Nothing seems to be happening. There are some actual things that are happening, but let's not worry about that right now. And eventually, all of a sudden, and it's not very sudden, this is in log scale, obviously, but eventually the model groks. It suddenly understands. That word grokking is a from some, I think, 1960s or 80s sci-fi book. It's a Martian word that means to understand deeply and I think suddenly. And basically the model will, despite nothing seeming having happened for a while, all of a sudden get better at this blue line, at this held out test data. And what happens once it has grokked is you can now show it any new question of the same type but that it has not seen before, and it will get the answer correct. Whereas before it grokked, you show it a new question of one that it hasn't seen before, and it can't do it because it has only memorized. The student who has the study guide memorized and but cannot do well in the test has not grokked. The student who suddenly has a eureka moment and like it all makes sense all of a sudden and they can now perform well in the test, that student has grokked, right? And then a paper, I believe, by Max Tegmark, if I remember correctly. I could be wrong about that though. There's a citation in here if you want to check it. A paper that I did a video on months ago at this point talks about how they analyzed the different two main circuits that are occurring in the model, circuits being like the actual algorithm within it. And what they found was that there is what they called circuit memorization, which is the part that is literally just memorizing every single data point it sees to the best of its ability. Then there is the generalization circuit. The first one is very big and complex because it takes a lot of effort and information processing to memorize every little data point. The second one, the generalization one, is very simple, streamlined, just a beautiful mathematical algorithm that keyword here generalizes, is capable of performing well even on data points that it has never seen before, right? So they actually found in these models that there's two different things happening, and you could kind of say that once the generalization circuit overpowers the memorization one, the model has grokked, right? And fundamentally, in this paper, I posit that we should define the word understanding as just on a given subject as just has the model grokked on that subject. The more technical term I propose, I call it uh, computational comprehension. If you want to reserve that word understanding for your feeling of understanding, I feel like I understand, you can keep that word if you want to. At the very least, give me computational comprehension. My kind of thing I want to posit in this paper is that we need to give the models more credit where credit is due, and we need to stop conflating our feeling of understanding, the way I feel having understood, to the actual neuron algorithm in my head that occurred while I was doing the task at hand, that algorithm is what did the actual understanding. Does that make sense? So I'm saying I am separating out this fundamental problem of consciousness, of sensation, of feeling from the actual algorithm that I am using in my head to do the task. And I'm saying that algorithm is what understands or has computational comprehension. You probably, if you're critiquing me right now, are probably not actually having a strict good definition of what you're saying. You are probably referring to the feeling of comprehension, how it feels, the whatever Greek philosopher called this qualia, the subjective experience, the the what it feels like to see the color red, right? What it feels like to understand. And so by that metric, I would say any model understands if it is capable of consistently with high accuracy answering questions that it has not seen in the training data set, then that means it understands that type of question. And like similarly to humans, right? You wouldn't say I understand uh, organic chemistry if I have never taken an orgo course before, right? But you would say I understand economics. I've taken a lot of economics classes and done very well in them. And even post my classes and post my tests, I have been able to succeed in an economics based job where I constantly had to test that knowledge, right? In this same way, we're doing a subject specific definition where I'm not saying that like ChatGPT understands everything. Certainly, I think a lot of the stuff it is doing is very obviously out of memorization. When you ask it to like, you can get it to like show that it has memorized an entire New York Times article, right? I'm not saying it understands in that case. It does seem like it's memorizing. I am saying that with tasks where it actually can generalize to just unseen examples, it is having computational comprehension by my definition. And so when we get back to this Chinese room paradox, right? What I'm claiming is certainly the the person in the room with the huge book or library of Chinese phrases, input, output, answers, right? Certainly that person does not understand. And that book itself is reflective of understanding, but the understanding fundamentally comes from whoever wrote that book. And it is unfair to posit this room thought experiment paradox without clarifying who wrote the book. The person who wrote the book in the system is the one who understands. Now, That is assuming that the person who wrote the book does have a simple generalizable memori like a generalizable circuit, right? Somewhere in their head. If they don't, then we're going back a level. You might say, based on this interpretation, that oh, the actual understanding is in the training data set of the LLM, that it comes from the humans, and that the LLM is just memorizing. Well, kinda. In cases where it actually is, like the book, just memorizing phrases, yes. But we have seen there's plenty of cases where these LLMs can, honest to God, respond to new combinations of tasks put together in things and just new examples of tasks that were not in their distribution. I think to whatever degree that a language model response has actually not been found on the internet somewhere, we should say that that is, and that it gets it right as well. I want to clarify that it gets it correct. We should say that is understanding, and also very dependent. My definition is very dependent on the idea of what we found with that memorize or that generalization circuit. Is that it's, to be clear, this generalization circuit is as low dimensional as possible or relatively low dimensional, meaning simple. So memorization is an inherently complex, high dimensional task. It requires that you basically use every single degree of freedom you have, whereas understanding, comprehension, generalization to unseen data necessarily, we know from this from that grokking stuff, involves low dimensional representations, as low as the actual dimensionality of the problem, right? Next point to point out, I wanted to say just also keep in mind it is totally possible to understand or know something without being conscious of it, without feeling it. Likewise, it's possible to be conscious of something without understanding it, right? So when people are out here arguing with me saying like, "Oh, humans understand, the AIs don't," I feel like I understand. Your feeling means nothing to me in relation to the word understanding. Now, I do acknowledge that you feel that you are like a conscious being with a subjective experience, yes, but you are falsely equating the word understanding, that concept, like to understand something, with your feeling of what it feels like to understand. And it is totally possible to know or understand something without being conscious of it.
Your feeling means nothing to me. No. Um, Actually, he's right. Feelings or qualia, how you feel about what something feels like, is completely different than if you were to open up your brain and look for the circuits that make you feel that thing or whatever. There's a difference between being the system that's having an experience about itself than being outside of that system and actually looking into that system and being like, oh, okay, this is how it works, right? One is qualitative, and the other is quantitative. Like, look, this is how many neurons they got. This is what they, this is a model that we put together of the brain that's going to be learning this and that. So it's not a. All right, I am back. Let's see how many people are in the chat. We're still rolling with two. It's just me and Trade Quest. All right, so okie doke. Are we cooked with O3? No, we're not cooked. It's the question is always a foregone conclusion. I think that's what it was. An end result regarded as inevitable. Oh, a conclusion formed in advance of an argument or consideration. Yes. It's always these types of questions on YouTube titles are always a foregone conclusion. I know, because I try to do the same thing to all of you. Okay. So enough of Tune Adorable. Thank you for holding it down for me, buddy. I already dropped you a like. Anybody who wants to check out more about different AI papers and just watch a machine learn, so this guy comes from a data science point of view. He's a data scientist, and he's not necessarily a programmer, where I'm like a programmer point of view, and I'm not necessarily a data scientist, although I do love it. Um, like data science interests me, and I've for a long time I've been in what's called a programmer analyst. Not like a quant or anything like this, but just, I can analyze, I can look at a situation, and I think that a large part of programming is actually analysis, more than typing syntax into a thing or remembering what functions an object has or things like this. That's all just book learning, book knowledge, remembering, grokking. That's the difference, right? You can grok something. Like you can remember something for by rote, right? Or you can actually grok it. So, 日本語難しいだね。日本語が難しいだね。Japanese is difficult, yeah. So, what we got here? Right, so now that I'm feeling frosty again, I'm about to try out this okay. So firstly, I should train the VAE with a much smaller chunk size. Secondly, the RNN needs to handle larger batch sizes of this. Can I get away with most of what you just said by changing parameters and running the whole stack again? And actually what I'm going to do here is I'm going to go back to this previous version of train. GitHub skills. So what I'm lacking and I'm trying to like gain in learning is the literal experience in building this. Yeah. Even though I'm not the one who's writing the actual code, for the most part, that's fine because I'm understanding each step, I'm running it, I'm seeing what happens, I'm understanding all of the code that's being written. I could break this down. In fact, I probably should break some of that code down. But I think that this gives us a good enough picture. We have our data preparation. Oh, snap. Wait, what? I think that was just a notification thing. Did I really not have any space note? Yeah, I got 6 gigs. 6 out of I got almost 1%, buddy. What are you talking about? Okay. It just couldn't do the notification thing because it's, I don't know, some Ubuntu thing. All right. So then, let's go ahead and try going back to GitHub. Let's go to Helios and let's go back to when we added the hybrid schedule teacher forcing thing. Oh, let's go back to the other commits. I'm back. So that was teacher forcing 1. Here's teacher forcing 2. Shoo! This is just 2 back. that stuff was added. And that stuff was taken out. And this literally made shit run way slower, exponentially slower. And it still output just a thing that I could not show you guys because it would break your ears. So, instead of that, what we're going to do is blah, 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 blah. Let's double team this. Give me a new chat. And I'm just gonna talk with it 4.0. Can you how do I okay. Is a new version of ChatGPT. That's not real. I mean, it's not really new. It's just, static text. Oh, okay. I could just intend to go back to a specific commit, but still want to modify and commit changes while staying on a branch. Set your branch to the specified commit. No, we don't want to do a hard one. We just want to undo all this shit. So, does that mean I need to go back to stuff? I think that's the place that I was at. Yep. Okay. Let's do this. We're not going to check out hard. We're just going to check out normal. Okie doke. So, I regressed back. Real-time demands smaller chunk sizes and a more carefully sized prior. Okay, let's pull in the latent prior. Now the thing is one of the other reasons why I went with this few samples is because literally if I go with, so there's one big problem. I don't think I have like enough, because this is accessing the hard drive every time it grabs those files, those like couple millisecond samples. So do I even need actually, let's do this. And in fact, I'm sick of hitting Shift Enter, so I'm just gonna pop open a new this. the biggest problem that I see is that we need to have a is a pain in the royal ass. So if we had some way to load the full audio files into memory and then during training just take random samples from that for the VAE, which cover the entire data set, and then for prior training we use a larger number of samples to train the prior. Like you said, something like 200 to 300 milliseconds. But that also comes off of the data loader. In fact, this new way to sort of load in data should also be used during inference, so it needs to be proper. So the new way to load data in data should also be used during inference, so it needs to be properly modular. Okay. And the models for VAE and prior. Let's rewrite everything to take your summary and my notes into consideration. Okay, so first one we're gonna have is the this first one is going to be okay, so this first one is we're gonna take the latent prior. That's latent prior.py. This is the train.py. And this is okay, so let's slap in the latent prior. Train. By the way, feel free to ask like feel free to ask any questions about any of this stuff while I'm working. If you have any questions, and let's grab config. So I'll be happy to answer them. Okay, so here we go. Let's do it. All right. Below is an updated end-to-end code structure that unifies these ideas. Woo! All right, let's see what it actually says about. Stop scrolling, dude. I swear they get this right and then they get it wrong, and then they get it right and then they get it wrong. Do you guys keep firing people? Is that the case? Anyway. Below is an updated end-to-end code structure that unifies these ideas. Random chunking from large audio files to train the VAE on small frames. Example, 10 milliseconds to 40 milliseconds for real-time capacity. Separate chunk sizes. In-memory or on-the-fly chunking. Modular, so you can easily adapt in the future. So you don't have to pre-slice every file manually or store thousands of tiny waves. because no, why would I do that? I mean, it's fine and everything for like toy examples, but I need a proper like data loader that sits in memory, because you know the actual song itself, if it's what is it, something like if you use just standard MP3 stuff or standard wave, something like 100 megs or something like that per minute of no 10 megs per minute, yeah, something like that. A single wave file for 3 minutes can be something like I don't know. The point is it can all fit into memory just fine. Well-chunked dataset, a custom chunked audio dataset that loads list of audio files from an index, optionally stores them in memory. You can load on the fly, randomly picks a file, randomly picks a random offset, returns the chunk of the specified size to each training sample. Yes, okay. So that's the chunk dataset.py. Train has the code to train VAE on short frames for real time. Has the code to train prior on slightly longer frames so it can see some local context. Use the existing encoder decoder. Then your config can specify parameters like chunk size VAE and chunk size prior. Okay. Okay, but we both understand that chunk size of the prior has the code to train the prior on slightly longer frames so it can see some local context. Uses the existing encoder, decoder, and latent prior modules you already have. Config can specify parameters like chunk size VAE and chunk size prior. So the question of mine is this chunk size, we'll read the code, but is this chunk size actually going to be chunk of the specified size for each training sample? So the actual chunk audio data set is going to spit back a chunk of this size, but does that mean, since you're using that vocabulary here, the terminology, that the chunk size VAE and the chunk size prior are going to be two separate chunk sizes that are actually longer, train the prior on slightly longer frames? Is the frame the chunk, and is that chunk, because what we're trying to do is we're trying to do this, right? We're trying to train it on essentially a sequence of smaller chunks that are at the same size as the prior. So let's see if it actually groks that. Loads a list of audio files and returns random short chunks from them. This is useful for training a real-time friendly VAE or prior model. Path to text file, chunk size. So this is just the, okay, this is chunk dataset.py. I feel like we should also change data prep to account for the chunk dataset, the chunked audio data object, but we'll get there. So here we are, inference streaming. That was that. I feel like I need to start putting stuff into even better organization, because this can just start to get really sloppy. And that's one of the biggest, most important things. You know, the only thing that actually exists in programming almost is organization. Organization of your code, because it's sequential, because it's non-sequential, because it's, you know, it uses this, it uses that, it's event-based or something like that. But you need to know where are your events, what are they named? Are they going to be, when you pull them up in your IDE, are they going to show up in alphabetical order? Or can they easily be found by typing? Like, that type of stuff. It's all stuff that like you don't normally think about when you're just thinking about a problem. These are interface hurdles, essentially. You know, because we still don't have a fully human interface yet for this. So, all right, cool. And I think I said something about memes on this or whatever on the title. I don't know, maybe I did. So. Yeah, we'll do some AI based memes. And if you're still there, you're not AFK. Trade. Once I do that here, like maybe 15 minutes or so, then you know, I'll take requests. Okay. Dataset equals latent chunk dataset. This is the train prior function. Okay. All right. Oh, I feel like I should, okay. Replace the commit hash with the actual hash of the commit you want to go back to. You can find this hash by running git log to view the comment history. Such repository attached head state, meaning you're not on any branch, but directly on that specific commit. Be cautious. Any changes you make here won't automatically belong to a branch unless you explicitly commit them to one. If you intend to go back to the specific commit, but still want to modify and commit the changes while staying on a branch, you can use git reset hard. That's what I would have done. But that's the problem with that. So if you're just experimenting and explore an older version of your code, want to ensure you don't accidentally lose progress, consider creating a new branch before checking out the commit. Nah. Soft, keep the changes made after the commit stage. This will move the branch pointer to specific commit, but so then wait. What if so git checkout main. So if I just want to merge, nah, I shouldn't do that. So a reset. I kind of like this one better, eh? But since I'm paying you guys, I'm not going to tell you which one I prefer. After after this, you'll be in a detached head state, meaning you're not on any branch. You can test the code as it was that at commit. Permanently retest your branch to a specific commit. If you want to move your branch pointer to a previous commit, hard reset, lose the changes made after the commit. Move the branch pointer to a specific commit and discard all the changes made after it. Soft reset. Yeah. Okay, so I use the commit hash. Okay. I mean, I guess it really doesn't. So Brandon. Okay, cool. Cool, 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 cool. Jesus. All right. So, now then, let's go. Did that? Wait. Okay, I did a hard reset. Could I have created a new branch? Yeah, sure. I mean, that's fine. Okie doke. So, let's take a look at get it. All right. So previous head position was switch branch to main. Your branch is up to date with origin main. Is it now? Is it though? Okay. All right. Chunk dataset pi. Oh yeah, I never got to actually making it. Nike. Okay. So I got a couple questions about the chunk dataset. Okay. Lots of questions for you, O1. You code while I... Well, actually, you tell me this first. Yeah, you think. Understanding the flow, verifying the... Oh, it stopped giving you like real things. It just starts telling you the details are not the actual verbose details anymore. Because they realized that people were using interface hacks to train their own models on GPT-4's thoughts because they made it so that it wasn't accessible via the API. Yep, I think I just did a whole video on that. Okay, key difference is that your VAE training dataset returns one small chunk per sample, useful for learning to encode, decode single short frame of audio, whereas your prior training dataset returns a larger chunk of audio that encodes to multiple latent frames. Okay. Okay, so I guess technically the question, so the interesting thing about the VAE is that we should actually get at the same size of VAE, we should get higher resolution of audio, higher definition of audio, so to speak. You feed that chunk into the VAE encoder and decoder, learn per chunk reconstruction. Each sample is just one chunk, batch size, one in chunk size, so essentially effectively has one time step from the VAE's perspective, or a very small number of latents if the encoder downsamples slightly. Okay, here we return a slightly larger chunk, 300 milliseconds. The larger chunk, when passed through the VAE, typically yields a time series of latent frames because the encoder's convolution downsampling might produce multiple latent frames from a 300 millisecond chunk. Okay, that makes sense. That's built into the encoder. Mu logvar, okay, self-encoder audio, mu transpose. So I just want to say something here. To those of you who think it's like a black and white thing, oh, you use GPT or you don't use GPT, it depends on how you use it. It's just like every other tool, right? If I'm trying to understand code that another programmer wrote, well, it's faster if I ask that person specific leading questions that will lead me to the answers that I want about their code, rather than trying to look through the code myself and understand everything. Now, it's just a matter of time efficiency. It has nothing to do with the actual, the wonderful act of learning itself. Though I am learning, I'm learning in a different way. I'm learning by asking a question and then inferring what's going on. And then this is also giving me examples because, it's way more verbose than a human could be in that period of time. So, yeah, I mean, I just really like the way that this all works. So for VAE, you want a short window, blah, blah, prior, you want a larger chunk. Okay, it's just restating the same stuff. Returns one short chunk, separation. Sweet, okay. So essentially this means, yes, I do want to use your code. I do want to update this. So, okay. So first off, we put the head back. We add a chunk data set, git add chunked data set.py. Git commit a m starting to chunk. Yeah, starting to chunk. Okay, and I think what Git actually does is tree off this whole commits now. So if I go back to commits, oh, I didn't push the commit. Right. Git updates were rejected with the tip of your current branch is behind. Its remote counterpart integrates the remote changes at git pull before pushing again. See note about fast forwards and git push. Oh snap, okay. Give me a. Oh, it's going through this one. Which one was it? It was 2 out of 2. It chooses the last one. As a standard loop would do. Wait, what? Wait, I just did a hard reset. Oh. That was what I was looking for, git force push. Use the force! Alright. Git push. Use the force. BAP. Okay. Also the other thing is, man, have you seen search results lately? They're highly. I mean, I like image search and stuff, but image search is also just turning into something like might as well be Civitai, just like searching through a whole bunch of AI generated images, and then um, the way that all that stuff works. I mean, really, if you start to think about the way that the internet works now, what used to be a completely wide open range of search spiders, what they were called. That's how you make a search engine. Is you have a little thing that goes in and follows links around and creates this sort of like a network graph structure in a database probably of all the sites and their content and stuff. And then if you're really cool nowadays, you set it up so that it just chunks all that content properly by the structure of the DOM, and then you take that and you go, okay, I want to plop this into a vector store, right? And then you've got a RAG system essentially, and then you have your search engine. I mean, that's what Google pretty much was. It's just that it was a secret what their secret sauce was, and now that's just called RAG. Um, okay, okay. So let's. Did my commit get pushed? Starting to chunk. Okay. What's in my commit? What's the diff? There's a chunk data set. Does my changes, is my other stuff back? Chunked audio data set. Where's my latents prior? Okay. Let's do that. It didn't change. Okay, in my train. Also did not change. Okay. Well. Okay, previous head position was this. Okay, so that's cool. We just sort of like reset the head a little bit, and now it's coming back. Yay, working with GitHub. All right, so collate latent chunks. Let's grab the new train. And was that it? Was it the only thing? Was that my example config? Train index, latent dim 128, chunk size, VAE 1920, about 40 milliseconds at 48K, 300 milliseconds at 48K. So really the prior is only going to have, it's going to have a little bit of, it's going to have a third of a second-ish, a 3/10 of a second type of a deal going on where it's like 0.3 seconds, let's say. Everything else looks the same. All right. Get the thing. Wait, what? Did you forget to import random? Ooh. Everything's all good until it's like got an error on random, right? This is like, what's the word? I don't even know what the word to use to explain this type of thing anymore. I'll just say Rain Man. If you've seen that movie, it's an older movie, but this person was super intelligent, but he couldn't function in the physical world so well because of how like super intelligent he was. I mean, essentially, I think nowadays you would just say that that's autistic. Um, anyway, though, point is, he could get a lot of other stuff wrong. So, so what I'm thinking is like, really, this is this system, O1. It's great. It's great at coding. I love it. But sometimes it makes the mistakes that like not even a junior coder would make because you would just see it right away in the IDE and be like, what? What is this? What's going on? Did I not get random? And then you would see it and you'd fix it. But this can't even test anything. So like if you try and think about this, there's coding time and then there's testing time, right? And when you've got code and then you've got a test that you could test that code on, or basically you can compile it and run it and see how it works. And you can visually check that code because we're making visual programs sometimes because we're still humans who have to interact with things. So like you have to make that leap. All right, so enough said. Let's keep going. We got the train, and then we have the new config with very nice comments. Thank you very much, O1. You are a very cute little commenter, aren't you? You make things easy to read, and you always think about working with other people because we're talking about Git. I mean, it's not that you think that, it's just that statistically that's what you should say. So, data prep, okay. Train. Latent prior, data prep, blah, blah, blah. Oh, yeah, okay, what am I doing? Keep getting, there we go. Oh. The content of the file is newer? What this? Use the actions in the editor toolbar. Yeah. Okay. Okay. Let's go, new flow. All right. I just be pushing. What are you doing today? I'm pushing it. Push it real good. Bum 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 bum. Push it good. Push it. Push it good. Ow, push it. Ow, push it. Ow, push it. All right. Enough of that silliness. Okay, let's go, new flow. Let's go. All right. I added one more O as well, just, that's for shigs and gigs. Uh-huh. Yeah, that looks about right. Okay. So now, what are we gonna do? He said, geez, why do I keep referring to him as a he? Only Claude is a he, because he's anthropic. Next steps in notes. Memory versus on the fly. If your data set is huge, use in-memory is false. If you have enough RAM, in-memory equals true. Might speed up training. Exact length of the decoded chunk depends on your encoder-decoder strides. If decoder is 8x upsampling, each latent from the frame might be 8x shorter than the raw chunk. Make sure your chunk sizes align. Wait. Each decoded chunk depends on your encoder-decoder strides. 8x upsampling, each latent frame might be roughly 8x shorter than the raw chunk. Make sure your chunk size aligns with how many latent frames the encoder outputs. Batching multiple latent sequences for the prior. We used batch size equals 1 for prior because each chunk can have a different latent time length. You could do dynamic padding if you want a bigger batch. Okay, we might do that. Increasing model capacity. If you still get beep-like results from the prior, try bigger hidden size or more layers. KL weight. If random latents are near nonsense, consider raising KL weight to ensure the latent space is more Gaussian. I would say that we should probably do that too. Did we have KL weight? Did you give me that in the thing? Did you give me the KL weight? Oh. With short chunk VAE plus slightly longer chunk prior plus random offset chunking from large files, you can accomplish real-time friendly latents since you're training on small frames and a prior that learns short local transitions in the latent domain. This should be significantly more flexible than the old 2-second snippet approach. Okay, cool, great. All right, let me get some water. Alrighty, and we're back. The data set returns one short audio chunk. Yeah, actually it's been a while since I've done so much talking. Okay. Let's try it, and this time it shouldn't take 2 freaking days. I literally trained that other one that like had that exponential, it had an inner loop in it basically, and that's why it took so long. And that was like, man, that took all night. I literally checked in the middle of the night like, oh, I hope my instance didn't stop. And it didn't. I mean, it stopped when I woke up roughly, and I caught it. And I downloaded that thing. It was only like 464 kilobytes. And seriously, it was the same size as my other prior file. So, yeah, like here's the prior final, right? And then here's the one that I downloaded. Still the same exact size, but just literally took exponentially longer to train. All right, so let's start off with, so we already have, okay. And this is a 4.0 question since I still don't got no great whatevers. And then what we'll do is right after this. That's not correct. Stop. Get this trash out of my, you can skip a separate offline data pre-processing step if all of your data is already in WAV format and you're comfortable loading them directly. You're okay with the dataset classes. We'll load your WAV files, resample to the target sample rate if needed, and pick random offsets to extract the chunks of the required data size during training. This happens in memory or on the fly depending on the in-memory flag and dataset logic, so you don't need to pre-slice or pre-save thousands of small WAV segments. pre-slice or pre-save thousands of small wave segments. Put your wave files, collect them in a directory, create a text file indexed using the list paths. Okay, I already got that. 2 short files. Keep it false, refund this each time, slow down training to stage 1. I mean, the training's not going to be that slow anyway, so. Okay. Let's just, you know what? Let's just go. And I feel like we don't need so many steps on the prior, eh? Yeah, 50 is going to be good. That's training really fast. Nice. Got all the way down to sub 1%. Okay. Great. Train.py. Train prior only. Pay epoch 50. Oh, it's only training on, oh, it still is only training on 12 prior epochs. Okay. Because it gets pretty down there. I mean, what is there really to learn? A little bit of like 100 millisecond sound dynamics. There's not really much that goes on in 100 milliseconds, so to speak. I mean, tons of stuff can go on in 100 milliseconds, right? So the actual dream on this is I'm not expecting this to have any structure whatsoever. You know, in fact, if I wanted to train something that would learn a higher level structure, I could actually train a transformer on top of these priors or something. All right, but you could see that this is, I mean, this is already down. It's down pretty far. So, okay, what did it say about something about inference? Uh-huh. Config, train prior only, blah, 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 blah. 300 millisecond random chunks encodes each chunk to latents and trains in next step prior. Perfect. Oh, man. This is exactly, I think this is way more close. This is closer to getting it. Make sure you pass enough steps to your desired audio duration. Each latent frame. Is the current inference.py going to work the same, or should you update it? As long as the VA architecture still uses a total stride of 8x. It should, yes. However much you set up an upsample factor, where the length, seconds, and upsample factor are rough estimates of how many latent steps are needed. So length, seconds, and upsample factor are rough estimates of how many latent steps are needed in order to generate that duration. Okay, however, if you change the overall stride downsampling in the encoder-decoder, for example, the decoder's total M-sampling factor is no longer 8x. Essentially, it's telling me indirectly that it doesn't actually remember that code. There's an each with stride 2, it says 2 by 2 by 8 bit text down something in the... You have 3 layers in each with stride equals 2. This indeed suggests a 2 by 2 by 2. Yeah, 2 to the cubed. In total 8, verifying the 8x factor. Each layer has a stride equals 2, therefore after 3 layers, an input length of t is reduced to t over 8. Not accounting for minor boundary effects from padding or kernel overlap. I don't know if there's any, well, okay. Upsamples a latent sequence by 2 by 2 by 2 overall. 2 by 2 by 2. 2 by 2 by 2. They went 2 by 2 by 2 because it was 3D. Outlength, in length, stride, blah, blah, blah. Using an X fact in the inference script. Summary, S3 stride, blah, blah. Existing wool. Given this architecture. Okay. Let's try to generate something that's not actually. Okay. Okay. Yes. Okay, it took 7 seconds again. Let me turn this down. Way down. God. Something is going on because there's loss. It's okay. There's loss. It just keeps outputting that blank goddamn signal. Just went through the entire thing. Still getting the simple signal. Can I seriously attach an audio file? You know, could I send this? Let me send this to you. Yeah, I can't. I can't, can I? Because you can only see things, you can't hear them. And even if you could hear them, you would be whisper, and you would only be able to try and understand voice in there and turn that into text. Because nobody made a model that just literally understands everything through voice. All right, so just went through entire thing, still getting the simple signal at that really annoying high tone. In fact, what tone is it? Oh gosh. Audacity. Audacity, you little port from Windows, you. Alright, so models, generated data test data, configs, checkpoints. Look at that. Look at the DS offset of that thing. I mean, it is doing something, isn't it? Hurts my ears just to listen to that. Turn that down even more. Okay. All right, so tracks. Yeah, just give me all of it. Plot my spectrum, babes. Ooh, look at that. Okay. So, oh, well, that's just not helpful. Looks like there's some stuff going on down there. And then there's some stuff going on up here, but why is it just like a straight up signal with no latent? You know what? Let's plot those latents again. It could just be because we don't have a diverse enough data set. Or I need to up the KL factor. But no, the KL factor is on the VAE. Training. KL weight. Okay. I'm thinking it's that we're not getting a Gaussian distribution from our latent space over the training data. Here's current UMAP plot, and we're not using the new data loader. So let's fix that. Tests UMAP. See, I'm telling it without saying it specifically in my paragraph that it's actually now in the tests folder. Just letting it know. Okay, so give me that, give me that, give me that. Oh, yeah, give me all that. Chunk-based loading from the UMAP generation rather than loading. Essentially, okay, so do we look at this data to see if we are getting a normal distribution or not? Switch to short chunk UMAP analysis for your, if you're, so BA is trained on short frames for real time. The code above in UMAP plot chunked provides an example of how to do that. The resulting UMAP might show whether your latents are forming a trivial cluster explaining the beep or a more complex manifold. So, latent manifold. I would say that we are not getting that latent manifold, and that is what, because like, okay, look at these things that are generated. Look at these latent manifolds. They look amazing. This is some just random ass graphics, but look at these. They're nicely ordered. They're nicely structured. Mine is just like a bleep blop bloop, you know. Throw it in there. Here's some like random scribblings of a crazed lunatic. So let's say switch to short chunk. The KL weight. Should I try upping the KL weight? Okay, so UMAP plot chunked. Let's just slap this here. Chunked UMAP dataset. Okay. 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 Config, VA checkpoint, index file data train, index, batch size 8, output chunk tmap, pingy. Okay. 2,965 latents over 128 dimensions. So oh, I mean that is a nice manifold. I don't see why. So now we're using Vision in O1. Woo! Error in input stream. Oh, come on. Okay, so you can't just look and see a blob. Okay, right. That makes total sense. Now I feel like a dumb butt. Alright, but that's fine, because that's what learning is about. Alright, so that confirms a normal distribution of the original high-dimensional space. Instead, UMAP is useful for visualizing whether your latent vectors form distinct clusters, or a single connected manifold. If you want your VAE's latent space to be close to N, to a normal distribution, I'll just say, NOI, N0I, NZOI, you need a different diagnostic, see below. Still, if your training set is fairly uniform and you've used a low KL weight, you often see a well-separated manifold in UMAP, rather than a tight Gaussian-like blob. I mean, it's pretty tight Gaussian-like. I would say this kind of looks like two continents. It looks nice. Dude, you did it right, UMAP. So, ways to check if your latent space is near. Sample means and standard deviations. Encode many chunks. Compute the empirical mean and standard deviation for each dimension. If your latent is truly near NOY, compute the KL divergence. Okay. So should we use KL divergence to actually try to, can we use? So how could we be smarter about the priors, and why the fuck are we still just getting that high-pitched tone? It looks like on spectral analysis it has a lower component, lower pitched, lower frequency component as well, but below human hearing range. What the fuck? Yeah, double question mark. In and outside the parenthesis. Alright, so you should increase the KL weight. Dream mode, be like suspicion that your posterior latents are actually near. That means random draw from produce out of distribution latents decoded as nonsense. Yes, increase KL weight. A higher KL weight pushes the encoder to keep chunks posterior distribution closer. This improves sampling at the cost of possible reconstruction quality. KL annealing. Another approach is to start with low KL weight, let the VAE learn to reconstruct well, and then slowly ramp it up. This gradually forces latents to become more standard, normal, without destroying the reconstructions too early. But if your entire data set is somewhat uniform, or you limit capacity in the model, increasing KL might cause posterior collapse or degrade reconstruction. Few notes. It's quite spread out. This suggests your short segments are vary across some acoustic dimensions. Okay. No obvious discrete clusters. Ooh, this is the part that I like. This is really nice. Good job. Thank you for looking at this with me, with your beautiful machine eyes. O1. No obvious discrete clusters. Means your data is somewhat continuous in timbre. I mean, it's all David Bowie. UMAP shape. The arc shape is just an artifact of how UMAP arranges neighborhoods in 2D. It doesn't literally imply a semicircular manifold in high D space. That's correct. So if you see you have broad coverage in 2D, it likely means the encoder is capturing differences among the short frames, but if it may not be forcing all the latents near mu equals 0 or omega equals 1, hence random samples from the normal distribution might land way off the learned manifold, leading to beep-like audio. Check means and variance. Encode your short chunks for each latent dimension computing. Consider a higher KL weight. Consider a more expressive prior. Like normalizing flow or diffusion in latent space. Okay. I mean, I'm just slapping this onto basically a vanilla RNN, so I'm not quite sure if that's actually going to work fully, but we'll see what's going on. Um, okay, we just hit prime time. I'm on four. I have four concurrent viewers. Would anybody like to say hi? Hello. And are there any questions anybody has, or like, is this? Are you guys just lurking? Like, there's no. Is there anybody here besides Trade Quest that actually would like to say hi? I mean, if not, that's fine. If you guys are just like AFK and you like to just listen to me talk about random stuff. My girlfriend, she says that sometimes when she needs to get to sleep, she just asks me to start talking about this type of stuff to her. She understands none of it, and she makes it very clear when her eyes glaze over whenever I start talking about it. So it's like perfect for sleeping, apparently, my voice and just talking about a whole bunch of geeky stuff that just sounds like a whole bunch of words strewn together in a language. Anyway, it sounds like an LLM is just out spitting junk. Junk that you might be interested in, though. Maybe. So, all right. So nobody said anything. That's fine. Let me do a. Hold on. Wait. I'm gonna do an emoji. Oh God, my phone. Wait. Oh, my emoji. Oh snap. She's gonna say hi to you. Hello. Wait. Oh hey guys. Hey guys. I didn't want to put that twice. Yeah, sure. I'll put it three times. Hello. 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 Um, cool. Right on. Well, I was just about to get tired and like walk away or something like that, but I kind of feel like this is getting good. We got four viewers. Man, I'm on a roll. My Twitch dreams are coming true. Yes. So how could we be smarter about the priors, and why the fuck are we still just getting that high pitched tone? It looks like on spectral analysis it has a lower frequency components as well, but below human hearing range. What the fuck? But apparently, though, I mean, I didn't read the rest of this part, so if your goal is to dream from random latents, you'd likely want a stronger prior alignment. KL weight. If you train on a small RNN or prior sample, but still get a beep, you might need a bigger prior and more advanced generative prior. So what do you mean on number 3? Explain. Validate reconstructions. If your VA reconstructs short chunks well, that's good. But for dream mode, you want a well regularized latent space. And then also the VAE, we have a test for that, and it does direct audio in and then audio out and reconstructs the audio just fine. Well, it did before. Let's actually do the VAE test. Is there anything I need from here, from the other things? Swoop. Okay, yeah. Because I got my init pi right there. B. Alright. Oh, right. happened? All right, we're back. My phone was just freaking out, maybe. Okay, so we got that. We got that going. That was good. Oh, does anyone know any tools that summarize valuable information and fact check web pages? Yeah. So, I mean, what are you looking for? Like a tool that already exists that you just want to pay money to? Oh, summarize valuable information. So you need something that's going to be a local model. CFG 338. Well, I'll let the lag get through, and then all that other stuff going on. Okay. So, Major Tom, Broski. All right. So what do you mean? Number 3, explain. Blah 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 blah. That's what we're saying here. Preferably a free browser extension. Oh. Summarize valuable information and fact check. So, actually, that's funny because I was thinking about this type of thing long time ago. A long time ago in AI years. And for me, what that was oh, but I could go the local LLM route, right? Yeah. I mean, essentially, you could go the local LLM route, and it could still be a browser extension. That's fine too. But so, like, what are you saying? You want to take the information from the page, run that through an LLM, get the summary out, ask for that task. Then you're gonna go to take that summary information and then figure something out with it, like give it some sort of a score, or, I mean, what do you want to do with that data afterwards? You're gonna fact check it. So it's gonna extract facts, or what are proposed as facts. I mean, it's really easy to get an LLM to go into to sort of this mode where it's like fact checking. You do have to be careful there because it does start to get very like woke fact checking on you. And I'm not even kidding. It's like not woke fact checking, but just let's say like cancel culture fact checking. Let's say it gets its fact checking information from like these news organizations who do really like the facts that are fed in through these news articles. You know, GPT did this whole thing with New York Times. They had this whole row, New York Times versus yeah, becoming a for-profit company, blah 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 blah. News that can reason through blah. Oh, okay, it's all just New York Times versus OpenAI. This was yeah. So essentially, the fact-checking stuff that it will be doing. Oh, you want to do anti-AI slopness? Well, what you could do is you could go to. So more you're talking about if this was written by AI, correct? Or do you just mean, given that AI hallucinates a lot, you don't want to just be believing random shit that articles say because there's an 80% chance that they're written, or 75% chance that they're written by AI? Is that what you're saying, CFG? I like your name because it reminds me of a configuration file extension. Yeah, I mean, it's definitely not going to go away, though. So what I would say is you kind of need something that's going to okay, because right, there's like, I mean, right, we could just do a search, right, for AI fact checker. Tell browser extensions to help you detect and avoid the trustedweb.org. Ooh, these guys sound interesting. Avoid fake news. Browser extensions, blah, 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 blah. Browser extensions, so on and so forth. I was written by ChatGPT. Meetup. No, just kidding. I'm just kidding, guys. Trusted web. I don't know you guys, so I'm not assuming anything. Oh, I accepted the thing. I accepted the terms. Now I'm locked in. Um, Dude, actually, the top 10 list of anything on any search engine has become there's this whole thing about enshittification. Uh, where was it? Where did it go? Where's my threads? Oh gosh, I shouldn't really be showing all this stuff, but whatever. I don't know. But I mean, just look up enshittification. Of the internet explained, or of YouTube, or whatever, of search. I mean, really, okay, here's for me. Here's the thing. I don't even use search anymore. Really, I rarely use it. Like, I may check the top thing on the right or whatever, because that's usually like the top result on DuckDuckGo or something. Um, but or use it for like image search, and in that case, I also use Yandex, because those guys are well, they're the Russians, but essentially Yandex just doesn't the Russians. Sorry, any Russians who are watching. You're not the anything. You guys are people. I'm just using my my Western tongue to speak. So, uh, but yeah, if you use Yandex, those guys, I mean, they represent to me holding on the OG search, and their image search is actually really cool, because you could search for anything, and then they have their actual AI makes sense. This is an AI that has existed for a while, like a machine learning thing. Let's see if we can get more. So it uses not only tags, but it also uses the actual sort of almost a vision model or whatever, and you get that. Plus, these guys don't do any of the Western style censoring. So, I mean, of course, they might do Eastern style censoring, but at least you can still get something. Like they still haven't messed with their algorithm so much, because look at them. They haven't included AI anywhere. They're not. They don't even. I haven't heard of them talking about including AI, and so that means that they're just still using their standard search system, which is great, because old search was good. This current search is just beautifully enshittificated slop. Yeah, exactly. So what I just use is I just directly use an LLM to talk to, because these things, I mean, even though they aren't directly learning or going onto the internet, I mean, I started a thing. Jeez. Okay, we're taking me way back in time, 19 or 20 months ago. Yeah, Google is shite pretty lately. So let's look at my repos. Oh, Meme Cat. I like you a lot. I like you so much. Meme Cat, get over here. She's sleeping. Okay, Morphon, Arjun. Oh, yeah. Okay, that was just like a very sort of a thing. I forked Langchain. Bashir, this is the LLM agent that's based off of you just like asking for stuff on the command line, and then it makes the command line arguments for you. The commands, and then what do we got? Oh geez, getting so far back. Echo. Oh yeah, so this was voice. It uses Mozilla TSS. This is from 2021, baby. Because I was sick of my my local voice thing. And then where was it though? Is it Rodin? Rodin? And I think somebody's taken that name now. Using Rodin. Where'd it go? Did I not? Is all that not in here? Oh. Oh, because this is by... No. What? Well, that's just derp. Okay, wait. LMML. Progeny. Okay, that's my reinforcement learning thingy. SD utils. That was like a thing that I released back when SD 1.5 was all the rage. But it was just released, and they had that... yeah, this was before automatic 11.11. I mean, so much things came up right then, you know? That's people started just working on shit to get you what you have now. Comfy UI, it's in this badass form. Trade comp. Okay, so that had beep boop. Boop beep boop. Growth. Okay, so it was actually no, did I never publish for them? I feel like I should have. You know what, dude? Fuck using mice. Nautilus, take me to, okay. So this guy was a guy, Rodin. This was actually a famous painter. But what I did here is I used a thing that goes into that. It essentially uses Selenium, which is an automation system for Python for browsers, and it takes Selenium and it goes in and it says, all right, here LLM, use your tool set as like all of the tools that you can possibly do on the page. Like this is the structure of the page. These are the links that you can click. These are the buttons and stuff that you can click. And here it's got like summary, blah, 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 blah. Now, obviously, this uses an OpenAI endpoint. It uses LangChain or something like that. But I'm sure that it could probably be rewritten into something that... What this would do, though, is it would go in and it would do Google searches or DuckDuckGo searches in this case. And then it would find information from there. And then it would follow through on those web pages and kind of do a little bit of spidering. And then it had a hookup to Telegram that basically allows me to, allows me to send myself texts so I can just text back and forth to it. And it takes a little while, you know, because it has to do its whole chain of thought and blah, 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 and do its summarization. And then it, just text it back to me on Telegram. So I didn't have to make an actual interface. I could just walk around with my phone and instead of browsing the internet myself, just send it to my secretary who's sitting at, running off of my computer at home or something. Like that Rabbit scam. It's so dumb. Rabbit. Pocket companion that moves AI from words to... Yeah. Well, anyway, I don't know if you know about this, but this is this thing. Large action model. It turned out that this was all a complete sham. Essentially they were just wrapping OpenAI just like everybody else. All right, so I don't know if I fully answered your question or not. I think I just probably gave you more questions. But maybe there's some good places to check out, like to search, to use or something. I did, by the way, on the same note as you, I've had this same exact thought myself, which was like, can I get something that will just like check? Yeah, God, that disaster, yeah. Man. Them pre-orders, dude. Flying back like hotcakes. Yeah. Essentially, I don't know, what am I doing here? Enshittification. All right, so I'm still getting that beepy thing. I don't know what the fuck this type of manifold is supposed to look like. Oh, geez, we're down to 2 viewers now again. Okay, great. That's fine. In fact, I'm gonna say that I think I'm done. It's already been like 3 hours, and we're almost. I think one day. I think on video 4, on 4 of this adventure, we're gonna get to something that's not just a mind-ripping, single high-pitched tone coming out of this prior thing, right? The VAE works. Everything like that works. We've made the code much more efficient. It trains faster. Now, what could be the problem? These things. Means invariances, we could do that. We can do higher KL weights. We can do considering a more expressive prior. And we could also do validate reconstructions. So, yeah. Cool. Cool. Man, this has been a little bit of a ride, but we'll get there. We will get there. Until then, please, if you liked, what was going on, give me a follow. If you're watching this on YouTube, subscribe on up. I try to keep it as light as possible, and I don't know if I'm hitting the mark or not because I haven't had much feedback yet. I try to make it so that I can get people who are interested in this stuff and keep them interested in this stuff without boring the crap out of them, or showing them that it's not worth it or something. I personally think that this is an era of coding that I love because I can expand my learning way faster than I could before. And we could talk about we could have a go. Geez, I feel like my next one on Friday, I'm gonna be doing some other stuff that's a little bit more inclusive of people, so that you guys can all so that instead of just chatting with you like this, we could do stuff that's kind of fun together or whatever. So yeah, but I didn't even notice that there was 4 people in here. One question before you go. Redirect all requests to OpenAI to a local LLM. Can you think of an existing solution that has the API in? Yes, VLLM. Okay, these guys. Ollama also has OpenAI compatible endpoints. So, chat completions, V1 chat completions, essentially, you do not have to change your end. You just have to change the actual host, and then the endpoint stays the same. And the actual structure that you get back and the structure that you put into it, everything is the same. And they have perfect usage examples over here on ollama.com. That's OLLAMA. And then VLLM, this one is for more, okay, it depends on it. I would use Ollama. I use Ollama for playing around locally, doing stuff that it's I'm not gonna be, this is a toy situation, or I'm just testing something out to see if I wanna actually go that route or not. And then I use VLLM for, because they have a Docker container that you can just throw in there. Does it handle OAuth? No, OAuth is something that you're gonna have to handle separately. That's a different layer of the application stack. So you got so I'll just I'll diagram us up here a thing. Oh, thanks. You opened a new window for me anyway. Okay, fine. All right. So in your application stack, what you got? I mean, I don't know what you have going, but I'll just show you an example application stack. So first you have, you might call this one Vercel interface. So /UX, right? And then you have OAuth. So then so then over here you have, so this in the current paradigm of stuff, right? Where you're doing you got serverless apps, right? So you're using these vendor vendor API. And the vendor API handles back and forth with you OAuth. So OAuth is like one of the services that are within here. And usually you'll be doing this OAuth stuff with your vendor API, like from there, and then they have like Vercel or whoever it is that you've got is doing that. I don't really want to write my own API, but I haven't found something that I would completely spoof OpenAI. Oh, like, so when you say spoofing OpenAI, what do you mean, like proxying it? Because, okay, because like what I really kind of want to say is that, I mean, yeah, what this level of, I guess what I'm trying to say is that at this level, you don't need an API key to call up Olama or VLLM. They don't have an API key because you're just running it locally or whatever. Like you're assuming that you're already inside of a trusted situation. And then if you're doing OAuth stuff, that's all going to be on the user, and that's all going to be in the interface. That'll have nothing to do with you calling up the LLM, which is completely done on the back end. Oh, reverse proxy to localhost? Yeah, dude. You just have, so whatever it is, I mean, okay, obviously, if you want to reverse proxy, you're going to run something like Nginx or whatever, Nginx, and then you're going to properly stick that reverse proxy to. Yeah, dude, I would say check out VLLM, and that might have like what you're looking for, and then check out Olama as well for like the quicker version of that, and you could just quickly get models loaded up in there, and then essentially what you're just going to be doing is you're just going to be having something which has API calls. So I think there's actually, oh geez, what are those? Okay, there's this whole set of things that I don't actually use, and they're like these packages that come together where it's like it gives you the interface. Wait, is there web local LM UI or something? LM web UI. Okay, something like this, right? Web UI recommendations for LLMs. Yeah. These guys. So, right, if you're not trying to like code something on the back end, then just using the interface. Olama LM Studio. Oh, okay. We'll send an OAuth request as the first one. Oh, so okay. Yeah, I mean it'll. Yeah, okay, exactly. I think we're on the same page. CFG config. But yeah, I'm going to get going. Please feel free to, like, I don't know, let me know if you think that we should do something more interesting or whatever on the next one. I kind of just like feeling all this out. They have also some OpenAI like endpoints, but not a full solution. Well, yeah, I mean. Those are the those are the endpoints, right? But then if you want the UX itself, so that you don't have to code an interface to it, then some of these guys. Ooga Booga, that was one. I've heard this one a lot. Ooga Booga. GPT-4, I've also heard of that one. In fact, look, here's you can see my history. Yeah, I mean, no one's going to have any sort of a full solution for any of this stuff. It's all like, it's all very experimental, and everyone kind of wants something different out of it, especially at different levels of usage, right? So, and I guess, you know, OpenAI is even trying to figure that crap out. Like, they're continuously trying to figure this shit out with our help, essentially. Is ChatGPT down? I'll leave you again with our previous. Oh, and then this one. Wait, what was the other one? Did I just stick it in downloads because I'm super lay? Where'd it go? Yeah. History of language model architectures. So first you have New Kids on the Block, then you got GRU, then you got Transformers. So we're still not quite on GRU. We're not even on LSTM. We're on RNN. That's like before LSTM. That's like almost DNA or RNA or something. You know, you're way back there. So anyway, guys, it's been fun. Check out my other videos or whatever. I do have, like, I'm starting to get Twitch. I'm starting to grok Twitch a bit. So like getting into some scheduling and stuff like that. Cool. Enjoy your evening or morning or day wherever you are, and peace out, y'all. Thanks a lot for showing up. I'm really happy about that.